Hello students, welcome to a series of additional mathematics program for grade 10 and grade 11. Our topic today is binomial theorem. This is the last and final part on binomial theorem. In today's lesson, you will learn how to use the binomial theorem for the expansion of a plus b to the power of n for any positive integer value of n, how to find coefficients of given powers of x, and how to find particular terms. The prior knowledge for this lesson, so you should be familiar with expanding products of algebraic expressions, manipulate simple algebraic fractions. You should also know the Pascal's triangle and the binomial theorem. So you will remember that in the first lesson, we have learned how to use the calculator to evaluate NCR, where NCR is in fact equal to n factorial over n minus r factorial times r factorial. We have also learned about the binomial theorem formula. So now we are going to learn how to find particular term. So this is the formula for the binomial expansion. So here we have the first term. This is the second term. This is the third term. Similarly, here we have the r plus 1 term, which is usually denoted by tr plus 1. So, example 1, find the fourth and fifth terms in the expansion of 3 plus x over 2 to the power of 7 in ascending powers of x. Now, we have just learned that the general formula for tr plus 1 is ncr, a to the power of n minus r, b to the power of r. So here a is equal to 3, b is x over 2, and n is 7. Replacing these in the formula, we get 7cr, 3 to the power of 7 minus r, x over 2 to the power of r. So now I need to find the fourth term. So I need to find T4. This means that r plus 1 is equal to 4. So solving this equation, I will get r equal to 3. So T4 means r is equal to 3 in the formula. This will give me 7C3, 3 to the power of 7 minus 3, x over 2 to the power of 3. And simplifying using my calculator to evaluate 7C3 times 3 to the power of 4 times x cubed over 8. This will give me 2,835 over 8x cubed. Now, to find the fifth term, this means I need to find T5. That is, r plus 1 is equal to 5. So r will be equal to 4. I need to replace r equal to 4 in the formula for tr plus 1. So this will give me 7c4, 3 to the power of 7 minus 4 times x over 2 to the power of 4. And simplifying, I will get 945 over 16 x to the power of 4. Second example, in the expansion of 2x minus half to the power of 10, we need to find part A, the term containing x power 6, and part B, the coefficient of x power 7. So here, A is going to be equal to 2x, B is minus half, and n is equal to 10. The r plus 1 will be equal to 10 CR 2x to the power of 10 minus r and minus half to the power of r. So I'm using this formula. Now to find the term containing x power 6, so this means that this should be equal to 6. So r is going to be equal to 4. 10 minus 4 will give me the 6 which I need. So 10 C4 2x to the power of 10 minus 4 minus half to the power of 4. Now, we're going to use the laws of indices. Remember, ab to the power of m can be written as a to the power of m times b to the power of m. So here, I have 2x to the power of 6. 2x to the power of 6 will be written as 2 to the power of 6 times x to the power of 6. And simplifying will give me 840 x power 6. So the term containing x power 6 is 840 x power 6. Now part B, I need to find the coefficient of x power 7. So here I will replace r by 3 so that I get 10 minus 3, which is 7. Simplifying will give me 10c3, 2 to the power of 7, x to the power of 7, times minus half to the power of 3, which gives me negative 1920 x power 7. But for the second part, we were asked to find the coefficient of x power 7. So the coefficient of x power 7 is simply negative 1920. We now move on to example 3. In the binomial expansion of a minus x over 2 to the power of 6, the coefficient of x cubed is 120 times the coefficient of x power 5. Find the possible values of a. So here also we will need to use the general term. The formula for the general term is NCR, a to the power of n minus r, b power r. So here a is going to be a, b is minus x over 2, and n is 6. So replacing this in the formula, we get 6 CR, a to the power of 6 minus r, times minus x over 2 to the power of r. Now, we have been given that the coefficient of x cubed is 120 times the coefficient of x power 5. So, the term in x cubed, to get x cubed, so r is going to be equal to 3. I replace r by 3 in this line. And this will give me 6c3 a to the power of 6 minus 3 into minus x over 2 to the power of 3. And simplifying, I will obtain minus 5 over 2 a cube x cube. Now I do the same thing to get the term in x power 5. I replace r by 5 to get minus 3 over 16 ax power 5. Now, the coefficient of x cubed is 120 times the coefficient of x power 5. So the coefficient of x cubed is negative 5 over 2 a cube. The coefficient of x power 5 is negative 3 over 16a. So here we have the equation. minus 5 over 2a cubed is equal to 120 times minus 3 over 16a. So dividing both sides by a and multiplying both sides by negative 2 over 5, we will get a square equal to 9. And the possible values of a will be plus or minus 3. We now move on to the next example. In the expansion of 2x minus 1 over x to the power of 10, find the term independent of x. So here a is 2x, b is minus 1 over x, and n is 10. So replacing these in the formula for the general term, I will get TR plus 1 equal to 10CR, 2x to the power of 10 minus R into minus 1 over x to the power of R. So again, here I will use the laws of indices. So ab to the power of m can be written as a to the power of m times b to the power of m. So here I will get 10CR, 2 to the power of 10 minus R, x to the power of 10 minus R. Now, minus 1 over x can be written as minus 1 times 1 over x. So here I shall get minus 1 to the power of R, 1 over x to the power of R. Now, 1 over x can also be written as x to the power of negative 1. So here I will get 10CR, 2 to the power of 10 minus R, minus 1 to the power of R, x to the power of 10 minus R, and this has been written as x to the power of minus R, because 1 over x is equal to x to the power of negative 1 times R, which is negative R. Now, we have also learned that a to the power of m times a to the power of n is equal to a to the power of m plus n. So here, we're going to apply the multiplication law here. We shall get 10CR, 2 to the power of 10 minus R, minus 1 to the power of R, and here I need to add, so 10 minus R plus minus R, which is 10 minus 2R. Now, we have been asked to find the term independent of x. What does it mean, term independent of x? This means that the resulting power of x in the given term must be 0. When we have x power 0, we shall have 1. So here, in this case, we have a term independent of x. There will be no x in the term. So I need to get x power 0. This means that 10 minus R is going to be equal to 0, and R will be equal to 5. So now I will replace R by 5 in the given expression. So T6, the sixth term, is in fact a term which is independent of x, and it's going to be equal to 10C5, 2 to the power of 10 minus 5, minus 1 to the power of 5, x to the power of 10 minus 2 times 5, 10. So 10 minus 10, I get 0. And evaluating this, I shall obtain negative 8,064. So this is the term which is independent of x, that is, which does not contain any x. So students, you now have some exercises to practice, similar to the examples which we have just seen together. So question 1, part A, in the expansion of 2 plus px to the power of 5, the coefficient of x cubed is equal to negative 8 over 25. And you need to find the value of p. Part B, you need to find the term independent of x in the expansion of 2x squared plus 1 over 4x squared to the power of 8. Number 2, the seventh term in the expansion of a plus bx to the power of 12 in ascending powers of x is 924x power 6. It is given that a and b are positive constants. First part, you need to show that b is equal to 1 over a. Now, the sixth term in the expansion of a plus bx to the power of 12 in ascending powers of x is 198x power 5. So using this sentence, you're going to get a second equation, and you will have two equations to solve simultaneously to find the value of a and b. Number 3. First part, the first three terms in the expansion of 3 minus 1 over 9x to the power of 5 can be written as a plus b over x plus c over x squared. You need to find the value of a, b, and c. In other words, what you need to do is just find the first three terms in this given expansion, and you equate it to this answer which has been given to you. The second part now, you need to use the values of a, b, and c, which you have obtained in the first part, to find the term independent of x in the expansion of 3 minus 1 over 9x to the power of 5 times 2 plus 9x to the square. Fourth question, first part, quite easy. You need to find the first three terms in the expansion of 2 minus x squared over 4 to the power of 5. And second part, you need to find the term independent of x in the expansion of 2 minus x squared over 4 to the power of 5 into 1 over x minus 3 over x squared to the square. You have question 5, which is a bit similar to question 4, except that here you have to find the coefficient of x power 4. You also have two links which you can visit to get additional information on what has just been explained to you. So in today's lesson, you have learned about how to use the binomial theorem for the expansion of a plus b to the power of n for any positive integer value of n. You have also learned how to find coefficients of given powers of x and how to find particular terms. So students, we have reached the end of this chapter. I hope you have been able to understand the different concepts. Now, I would advise you to work out the questions found in your textbook. In case you have any question, you can contact your teacher. You can ask your parents or even your friends. So until we meet again, it's goodbye from me.